Welcome, my friends. In this video, I'll be discussing section 2.4, clustered bar graphs, specifically for conditional distributions. Here's an example of a clustered bar graph for the conditional distribution of expected grade in Stat 215 based on sex. When creating a clustered bar chart for a conditional distribution, each set of bars will be clustered by your explanatory variable, in this case, sex. Recall that another name for the explanatory variable would be the independent variable. The horizontal axis will list the levels of the response variable, in this case, expected 215 grade. Recall that another term for the response variable would be the dependent variable. We usually set up our problem such that we may have the belief that the explanatory variable has some impact on the response variable. In this case, we may have the belief that the sex of a student has some impact on their expected final grade in the class. So that would mean that we may believe that either males or females have a higher expected final grade in their Stat 215 class compared to the other sex. The vertical axis on the clustered bar chart is going to list the conditional percentage of each grade given the indicated sex. For example, out of the females, 60% expected to get an A. Out of the males, 66% expected to get an A. This is why we relate this to a conditional distribution. Each of these percentages is conditional upon the sex of either male or female. So given or conditioned on you being a female, for example, there is a 37% chance that an individual expects to get a B in the class. Note that all the bars from one sex add up to 100%. So for males, 66 plus 32 plus 2 adds up to 100%, or for females, 60 plus 37 plus 3 adds up to 100%. Now we can use the clustered bar chart to assess the independence or dependence of our variables. If the bar heights for each cluster are approximately the same, we would say that the variables are independent. If the bar heights in each cluster are very different from each other, we would say that the variables are dependent. In this case, the bar heights are approximately the same for each of the expected 215 grades. So for that reason, we may say that sex and expected grade are independent. Your expected grade in the class does not really depend on you being male or female. If you are male or female, then you still have approximately the same chance of expecting an A, a B, or a C. Let's take a look at another example. This example is based on a conditional distribution that we looked at in a previous video. Here, our explanatory variable is worker type, as either executive or production worker, and our response variable is political affiliation, as either Democrat, Republican, or Independent. Here's what the clustered bar chart would look like. We have our response variable, which is political affiliation, represented on our horizontal axis, and we have our explanatory variable, which is worker type, represented by the clusters. As we mentioned a moment ago, the conditional distribution can be graphed to assess independence. Here we can see, if you are an executive, you are much less likely to be a Democrat than if you are a production worker. We have the flip situation for Republicans. If you are an executive, you are much more likely to be a Republican than if you are a production worker. For independents, if you're an executive, you are more likely to be an independent than if you are a production worker. If we have similar bar heights, that's going to suggest independence. And if we have different bar heights, that's going to suggest dependence. So in this case, we have a pretty dramatic change between the bar lengths of the three different categories. So we could say that worker type and political affiliation are dependent. All right, here is a problem for you to try. Consider the following conditional distribution of sex and drink preference. We have the sex as either male or female as the explanatory variable, and we have the drink preference as either coffee or tea as our response variable. Construct a clustered bar graph and determine if the variables are dependent or related or independent, not related. Recall that when you are creating a clustered bar graph, the response variable, which in this case is going to be drink preference as coffee or tea, will be represented on your horizontal axis, and you're going to be clustering the bars based on your explanatory variable, which in this case is sex. So go ahead and give that a try. All right, that's all I have to talk about in this video, so I will see you in the next one.